All right. So enough looking at that, and let's start lecture. So we're in chapter 6. Big picture, what's chapter 6 about?
Angles and triangles.
Angles and triangles now.
Yes.
We had our postulates for congruency. In particular, we're focusing on congruency between angles. Or at least that's what we've been focusing on so far. And so we already had our postulates for congruency between line segments. Now we introduced our postulates for congruency between angles. Because anytime we're talking about two geometric figures somehow being the same, we're always talking about their segments being the same and or their angles being the same. So with all other congruences, when I want to talk about two triangles, two squares, of any polygon being congruent, it's ultimately going to reduce to talking about their segments being congruent or their angles being congruent. So let's go over the postulates that we've introduced so far. What was our first postulate that we introduced for the congruency between angles? This was the existence postulate. This was if I give you some angle.
There's a postulate that's the same angle.
If I give you some angle, and on a line you have a ray, then there's a ray I can put on either side of the line such that the resulting angle is congruent to this angle.
Right.
So I can put a ray up here. I know I can construct the angle here such that this is congruent to this. I can also construct a ray down here such that this is congruent to this. Right?
Right.
So that's the existence one. Now it also had a second part to it. The second part to it is all straight angles are congruent. This was if you don't have a straight angle, you can do this. And then if it's a straight angle, all straight angles are congruent to each other.
Right.
That was postulate 1. Postulate 2 is the one that says that angle congruence is an equivalence relation. In other words, it's reflexive, symmetric, and transitive. Every angle is congruent to itself. Reflexive. If angle A is congruent to angle B is congruent to angle A. Symmetric. And if angle A is congruent to angle B and angle B is congruent to angle C, then angle A is congruent to angle C. And we call that
No, it's transitive, right?
transitive property. There we go. Reflexive, symmetric, transitive. That's what it means for it to be an equivalence relation. Now, our other one was adding angles together and subtracting angles. What's it called? The mnemonic phrase we remember for it is that equals added or subtracted from equals are equal. That's just what we remember in our heads. Pictorially, what this meant is if I have angles that look like this, you probably remember this picture. If I know that this is congruent to this, and I know that this is congruent to this, then what?
Then the whole thing together is congruent.
Then the whole thing together is congruent. Or similarly, if I knew, rather than that, if I knew this is congruent to this, and I knew that this whole thing is congruent to this whole thing, then what else?
Then that bigger one is congruent to the other.
Yeah, then this piece is congruent to this piece. And vice versa if I would have swapped the known piece to the other side. And so, equals add to equals or equals subtracted from equals or equal are the way we remember it. But that's the actual picture. And then finally, our big postulate is the side angle side postulate. What does the side angle side postulate say?
If you have a triangle and it has a side equivalent to another.
So if I have AB congruent to A prime B prime,
Right. Then you have the angle B.
we'll use A.
Okay.
A congruent to A prime.
And you have
And then
AC
another
is
side that's
congruent to
congruent
A
to
prime
the
and
other.
C prime. And those two triangles are congruent.
We introduced the side angle side postulate before we introduced the definition of congruent triangles. Because the definition after we introduced it is the definition of congruent triangles. So it's not those triangles are congruent. It's that then this angle is congruent to this angle, and this angle is congruent to this angle. And that's all it gave us. It did not tell us about this side BC related to B prime C prime. No. That was a side angle side postulate. We will prove the side angle side theorem for showing triangles are congruent. So we then introduce a definition of what it means for two triangles to be congruent, and it means exactly what you think it means. It means all three of their sides are congruent to each other, and all three of their angles are congruent to each other. Now remember, the order very much matters here in how you write these. Right? When I say that triangle ABC is congruent to A prime, B prime, C prime, I'm saying that segment is congruent to that segment is congruent to that segment, and that segment is congruent to that segment, and that angle is congruent to that angle is congruent to that angle, and that angle is congruent to that angle. So the order matters. If I would have swapped the A prime and the C prime here, it would be saying something very different. Okay. And now we were getting to some of our basic side angle side theorem, or some of our basic congruency theorems that you've come across before. So the first one, Theorem 6.4, this is our side angle side for saying that two triangles are congruent. So this postulate, the side angle side postulate, does not say two triangles are congruent. Notice it never said anything about BC related to B prime, C prime. This theorem is going to say if you have this picture, it turns out that this side is the same as this side as well. That's what Theorem 6.4 is going to be. Make sense?
Yeah.
So let's prove Theorem 6.4.
We have not done that yet.
We have not done that yet. I wanted to start with it since I thought it would be a good reintroductory of the postulate. So Theorem 6.4. Let triangle ABC and triangle A prime, B prime, C prime. Keep losing it. Let those triangles such that well, we're doing side angle side. I'll just pick it, doesn't matter. Such that AB, oops, forgot such that AB is congruent to A prime, B prime, comma, angle A is congruent to angle A prime, comma, and what's the last one we used? We used AC. And AC is congruent to A prime, C prime. Then, what are we trying to prove? Triangle ABC is in fact congruent to triangle A prime, B prime, C prime. In other words, if I have two triangles and I know one of their sides are congruent, an angle and a side, angle, side, then the two triangles are congruent. Here's our definition for triangle congruence. This is what we're trying to prove. Okay. Sorry, I missed my let. Theorem 6.4, let. And then here's our picture. We already have our picture right here from this postulate. So here's a picture that we're looking at. What's step one? Maybe we'll redraw the picture somewhere over here.
Yes.
Let's give me a rough idea of how many lines I'm going to use to do this. Okay, should have plenty of space if we draw the picture down here. So what does our picture look like? We've got two triangles.
AB is congruent to A prime, B prime.
So we have A, B, C. Sorry, get out of your way.
Yeah.
A prime, B prime, C prime. I know AB is congruent to A prime, B prime. I know this angle is congruent to this angle. I know this side is congruent to this side. Okay, I'm trying to show that these two triangles are congruent. Right?
Yeah.
Okay, so what am I going to do next?
We're
Trying to prove it.
We're going to show that.
I need to show that that angle is congruent to that angle is congruent to that angle, and this side is congruent to that side. And then we're done.
Yeah.
Okay. So what's first?
Well, A and B is congruent to A prime, B prime. So I have to say it anyway. So assume that.
That's already given to me.
Since it's already. Oh, so we don't have to write it down. Or
Yeah, it wasn't if, it was let. So you
Let.
can already assume you have what's let. If it said if, then I would have started out with let that.
Yeah.
So we'll assume we already have that and continue from there.
Let A,
So now what do we do?
Would you even be able to prove it without link? Oh,
A bunch of.
since
Oh.
postulate,
Since AB is congruent to A prime B prime, angle A is congruent to angle A prime, and AC is congruent to A prime C prime, then by at the same time, then by side angle side postulate,
ABC congruent to A prime, B prime, C prime.
now what does the postulate give me? The postulate gives me that if we have side angle side and side angle side, then that angle is congruent to that angle and that angle is congruent to that angle. That's all it gives me.
The triangle's not congruent.
It doesn't give me that the triangles are congruent. That's what I'm trying to prove. So then I know angle B is congruent to angle B prime, and angle C is congruent to angle C prime. Okay, so now I know that this is congruent to this, and I know that this is congruent to this. What remains? I need to show that this side is congruent to this side, right?
Right.
Yes.
So how am I going to do that? So, I'm not sure where I want to put my point. I'm going to pick a point D prime here. And I'm going to pick it such that this length is congruent to this length. And then I'm going to show that D prime has to in fact be B prime.
Okay.
And therefore, that length is the same as that length.
Yeah.
Okay.
Wait,
so,
you gotta prove it, right?
yes, I've got to prove it. So, number 2. Let D prime on the line through B prime and C prime such that C prime D prime is congruent to CB. All right, you with me?
Yeah.
Maybe draw a separate triangle out here so that you don't get confused in this picture. So now, redrawing this picture down here, I have another triangle that I want to draw for you. Here's A prime, here's C prime, here's D prime. And I know that that is the same thing as that, it's the same thing as that. I know that that angle is the same as all those angles. And I know that this side is the same as all those sides. Okay, so I just took this inner triangle and redrew it down here. If you would have if we would have drawn a line through here.
Yeah.
So that triangle, we redrew it right there. You with me?
Yeah.
So now, consider this angle right here. How does this angle compare to this angle?
The side angle side theorem.
They're the same. We have side angle side, side angle side.
Theorem.
And so,
Or postulate.
using this postulate, this angle has to be the same big as that angle.
Same thing with D.
And so does the other.
Same thing with D, but we just need it with 1. So,
Oh.
3. Then, comma, since D prime C prime is congruent to that, maybe, how do I usually write that? The C first? Since C prime D prime is congruent to CB, angle C prime is congruent to angle C, comma, and A prime C prime is congruent to AC, and A prime C prime is congruent to AC, since that, comma, then by the side angle side postulate, angle D prime A prime C prime, angle D prime A prime C prime is congruent to angle A, is congruent to angle A prime. You follow that? We're looking at this triangle and this triangle, right?
Yeah.
Let me redraw this green angle up in this picture. That's this green angle right here. And I'm wondering, how does this green angle compare to, well, I'm wondering how does this green angle compare basically to angle A prime? That's big picture. I'm getting a shot, they're the same angle. And since they're the same angle, it turns out that D prime and B prime are going to be the same point.
Right.
That's big picture how we're going about this. Okay? So we took this triangle and we redrew it down here. Now, if you look at this triangle and this triangle, we have side, angle, side, side, angle, side. And so their corresponding angles have to be congruent. This angle has to be congruent to that angle, and this angle has to be congruent to that angle. All we're going to focus on is this angle. So this angle, D prime, A prime, C prime, has to be congruent to angle A. Angle D prime, A prime, C prime, that's the green one, has to be congruent to angle A. But I already know angle A is congruent to angle A prime.
Which by the flexive, I can't remember which one this one.
No, it's by this first postulate. That on a given side of the line, there's one and only one angle congruent to a given angle.
Right.
So 4. Then, I'm not sure the best way we want to say this now. Looking at the point D prime. So then D prime lies on angle A prime. And so D prime is equal to A prime, or B prime.
Wait.
Yep, let's follow that out for a second here. So D prime, this angle and this green angle and angle A prime are actually the same angle. Right?
Yes.
Yes.
So the green angle and
Oh,
all
yeah,
of A
yeah,
prime
yeah,
are the
yeah.
same angle.
Yeah.
So the point D prime has to lie on this angle, which means it has to be on this side as well. So I know that D prime is on the line through B prime and C prime. D prime also has to be on the line through A prime and B prime. Maybe that would be another way to say it. D
Yeah.
lies on the angle A prime. And so D prime lies on the line
AB.
through AB. Remember AB, or A prime, B prime. Remember A prime, B prime is a segment.
Yes.
So then D prime lies on the line through A prime and B prime. And so D lies on the line through C prime and B prime. And D lies on the line through A prime and B prime. D lies on both those lines. D prime does. If I tell you I'm thinking of a point, I'm not going to tell you which point, but
So-
it lies on both those lines, where is it?
It's at the intersection.
It's the intersection. Where do these two lines intersect?
At B.
B prime.
B prime.
They only intersect at a single point. D prime's on both of them, so D prime's where they intersect. So B prime and D prime are on the same point.
Right.
Then D prime is equal to B prime, comma, and so we're done. And so BC is congruent to B prime, C prime. And so BC is congruent to B prime, C prime, which gives me that triangle ABC is congruent to triangle A prime, B prime, C prime. So there's the first of our congruence theorems. Any questions on that theorem? No?
Yeah, okay, I got it.
Good.
My question is, why doesn't postulate SAS do that?
Because we don't need it to do that.
It can it?
Yes, we could have made our postulate that whole theorem.
Why didn't it? So we didn't need it to? Sure.
The idea of a postulate is to reduce it down to the simplest things we can get.
Okay.
Because fundamentally, I mean, even for application purposes, you go and you apply geometry to some field. How do I know that I can go and use geometry to do something like physics? How do I know I can use geometry to describe this space that we're currently occupying? How do I validate that?
What do you mean? I don't see it. That's
So, you know that geometry, when I talk about a line, you can't show me a line. There's no such thing as a line in this universe. It's a completely abstract concept. There's geometry. And then there's this physical universe that we're in.
Yes.
Two completely separate things.
okay.
We happen to use geometry to describe this universe all the time. We use geometry when we solve like physics problems. I don't know you. I guess none of you have done physics. First thing you do in physics, you set up a reference frame, some coordinate system, but you start out by imposing geometry on the system. How do I know I can use geometry to describe this space? How do we validate that? Rather than thinking about our postulates, let's go back and think about Euclid's, or easier ones to think about. So Euclid's postulates, we'll just do a couple of them. His first postulate is that 2 points define a line segment. His second postulate is that if you have a line segment, you can extend it indefinitely, as much as you want. His third postulate is that if you have a point and a line segment, you can construct a circle. So here's his three postulates. He has two other ones. But the point is, I look around at the space around us, and I check, is it true in this space right here, and with the concept I have of points and lines, that if I have 2 points in this space, that gives me a line segment in this space?
Yes.
Yes. Is it true that in this space, that if I have a line segment in this space, I can extend it indefinitely?
Yes.
Yes. And go on our checklist and validate that in this space, with our concepts of points, lines, and planes, that they satisfy these postulates. If they satisfy all the postulates, this space does, what does that mean? That means all the theorems work in this space as well.
Right.
Because the theorems are the logical implications of the postulates. So we start with a bunch of postulates and we show what their logical implications are. Then you go to some real world scenario. And you say, do the postulates hold in this real world scenario for this thing? If it's yes, then you get all of geometry for free. You don't have to go prove that in this space the Pythagorean theorem holds. You get that for free because it's a logical implication of your postulates. So you validate the postulates in whatever your application is, and if the postulates hold, you get all the theorems for free. So you're trying to reduce your postulates to as simple a things as you can to go check.
Right.
And so if you want to make sure that Euclidean geometry works in this space, here's one of the things that you have to check. Make sense?
Yes.
Alright, let's move on to the next theorem. Angle, side, angle. So, theorem 6.5.
Yes.
So, let triangle A, B, C, and triangle A prime, B prime, C prime, such that this time we're going to have angle, side, angle. Let me see which angles I choose here. I assume I use A prime and B prime. Nope, I use A and C. All right. Such that angle A is congruent to angle A prime. AC is congruent to A prime C prime. And angle C is congruent to angle C prime. Then triangle ABC is congruent to triangle A prime, B prime, C prime. Okay, let's draw a picture down here really quick to help us think about this. So we've got our two triangles.
There are seen on
So we've got
angle A.
A, B, C, A prime, B prime, C prime. I know this angle is congruent to this angle. I know this side is congruent to, it's congruent to this side. And I know that this angle is congruent to this angle. Okay. So that's what we're stuck with. Now what?
Well, since AB is congruent, since angle A is congruent to angle A prime and angle AC and AC side AC is congruent to angle to A prime C prime and angle C is congruent to angle C prime. Then by the angle side angle postulate, then
We don't have an angle side angle postulate.
no,
We only have a side angle side. And it turns out this is enough of a postulate to prove all three of these congruency theorems that we want.
Well, since
So we got to set up some sort of a scenario where we can start using those. I need two other sides to somehow be congruent. So we're going to pick a point that gives us what we're essentially trying to get here. So I think I'll pick D prime. Let's try and be consistent with how we did it here, since it's going to be similar type of thinking. So I'm going to pick D prime here,
And you're gonna
such
put
that
D
this
prime and B
is
prime
congruent to
as the
this.
point.
Sorry, what?
And you're trying to prove that D prime and B prime are the same point.
If D prime and B prime are the same point, what does that give us?
they're congruent.
The triangles are congruent. How do you know that?
It's a side angle.
By side angle side from our previous theorem. Our previous theorem says if we can get side angle side, then two triangles are congruent. So you're 100% right. It's the exact same thinking. I need to show that D prime and B prime are in fact the same point.
Okay.
So one, let D prime on the line through C prime and B prime such that C prime D prime is congruent to CB.
so why do we have D prime? What purpose does it serve for?
So I choose D prime here so that this length is the same as this length, right? If it turns out that D prime and B prime are in fact the same point,
That means that side is.
then that means that this side is congruent to this side. And then I know side, angle, side, and so by the previous theorem, the two triangles are congruent.
Okay.
Make sense?
Okay.
Okay. So, let D prime there. Maybe do what we did in the picture over there and draw our separate triangle with D prime to help us think about things. That was a bit weird. Something like that. So here's D prime, here's C prime, here's A prime. Okay? And now I know that this, and this. Okay, so what else do we know?
Well, we know that angle A is congruent to which you already wrote down.
We know angle A is congruent to angle A prime. Oh, sorry. Okay, yeah, that's true.
Yeah. Angle AC is congruent to A prime C prime. That side. There will AC and A.
Let me kind of do what I did over there. So this, if we created this dotted line, that's the triangle we made. Then we have this other angle here. our green angle.
Yeah.
How does our green angle compare with angle A?
They're congruent.
Well, they're not.
Our green angle. Oh yeah, congruent.
How does this triangle compare with this triangle?
They're the same.
Let's say, yeah.
Angle
They're
side,
congruent.
They're congruent, yes. Let's say they're
Oh yeah.
Then triangle D prime C prime A prime is congruent to triangle BCA by side angle side, which gives me that angle, this angle, D prime A prime C prime, is congruent to angle A, which we already knew is congruent to angle A prime. Right? Since this triangle is congruent to this triangle, this angle has to be the same size as this angle. Since this triangle is congruent to this triangle, this angle has to be congruent to this angle. With me?
Yeah.
We already knew that this angle was congruent to this whole angle.
Right.
So the green angle is
The wing.
congruent to A prime. So 3. Then D prime lies on angle A prime. Which gives me that D prime lies on the line through A prime and B prime. Right?
Yes.
Because it's on that angle. What is the angle A prime? This is the angle A prime. I know a D prime lies somewhere on that angle.
Right. But it doesn't lie through the angle on through A and B because it is B.
So D prime lies on the line through B prime and C prime. We knew that from the beginning. Now D prime also lies on the line through A prime and B prime, which gives me that if D prime's where this line intersects and where this line, or if D prime's on this line and this line, it's on both of them, then it's where they intersect. They only intersect at one point, so that gives me that B prime is equal to D prime.
Right.
Now if D prime's equal to B prime, then what?
That means that angle,
The same
the
triangle.
triangle A prime or C prime is congruent to.
You're skipping a step. So then this side is congruent to this side.
Oh, yeah.
So then C prime B prime is congruent to CB.
Right.
And now we can use side, angle, side, side, angle, side for those two triangles.
Right. How's this
So-
proving angle side angle though?
Since this is congruent to this, since BC is congruent to B prime C prime, that's what we just barely figured out right there. And angle C is congruent to, since angle C is congruent to angle C prime. How do I know angle C is congruent to angle C prime?
Because we told that.
That was our given information. Oh, wait.
Well, no, we never said C prime was congruent. Oh, no, yeah, we did. We didn't do BC.
Oh, yes, there it is.
Oh, yeah.
Right.
Yes, we did that. So angle C is congruent to angle C prime. That was given information, comma. And AC is congruent to A prime C prime. And AC is congruent to A prime C prime, comma. Then triangle BCA is congruent to triangle B prime, C prime, A prime by side, angle, side, and now we mean the theorem. Usually from here on out we mean the theorem, not the postulate.
So I still don't understand how that proved angle side angle.
That's all we do in the beginning. All we do in the beginning is that A was congruent to A prime, AC was congruent to A prime, C prime, and C was congruent to C prime. That's all we started out with.
So in the beginning we knew the angle side angle. We knew
In the
angle
beginning, we
side
knew angle, side, angle, and we needed to prove that that implied the two triangles were actually congruent,
Which you did.
which it did. All we needed to do was use that information to prove that this side was congruent to this side. Once we had that, then our previous theorem takes over from there.
Right.
And we didn't need to go through the pains of showing that this angle is actually the same as this angle too, and that this side is also the same as this side too. We could have done all that and spelled it all out, proved it for each piece at a time, but we just used our previous theorem. Any questions on that?
So all you try to do is when you have angle side angle, you just try to find the side angle side and then it can prove itself by
As a general rule, you want to use your previous theorem for your next theorem. Usually the author sets it up in the book so that that's something you can do. Not always the case, but usually it works out. All right, let's move this to the next board.
Should I change the clock or does it work on
Mountain time changed, so it should change as well. Most of these aren't really drawing very well. All right, now we got to do the side-side-side theorem. So theorem 6-7. So theorem 6-7. So let triangle ABC and triangle A prime, B prime, C prime such that AB is congruent to A prime, B prime, comma, let's see, BC is congruent to B prime, C prime, comma, and AC is congruent to A prime, C prime. Then triangle ABC is congruent to triangle A prime, B prime, C prime. This marker is not doing great. All right, let's draw our picture at the bottom. So our picture. We've got A, B, C, A prime, B prime, C prime. A, B, C, A prime, B prime, C prime. And what do I know? I know that is congruent to that. I know that is congruent to that. And I know that this is congruent to this. Okay, so what is going to be the hard part of this proof? What do we have to do?
We have to prove an angle is congruent.
All we need to do is then show that one of the angles are congruent. And from there on out, we're good. Hopefully I left myself enough space to draw out this picture. I may need to draw my prime one a little bit better for my picture. Draw that straight. Keep this one kind of shallow, and then that one steeper so it's clear. And keep this on the outside, because I'm going to have to flip down. A prime, B prime, C prime. Okay. Okay, so first thing I'm going to do is I'm going to construct an array with a congruent angle. And let's see, I'm going to use B prime. So I'm going to construct an array here, down here. this proof's going to look a little bit weird. I'm basically going to construct a triangle down here that's congruent to the given triangle, and then it's going to be congruent to this. That's how the proof's kind of going to look. So first thing I'm going to do is construct my angle here. Put a ray here, going to some point D prime, we don't know. So that this angle is congruent to this angle. Okay, so 1. Construct ray A prime D prime such that angle C prime A prime D prime C prime A prime D prime is congruent to angle A. Now we're going to mark off a point. How do I know that I can do this?
By
That I can
postulating phi 1.
Yeah, by our first postulate here. That's what that first postulate says we can do. Okay, now I told you basically what I'm going to be doing in this picture. I'm going to construct a triangle down here that I know is congruent to this thing. So I force this angle to be the same as that angle, right?
Right.
Now I'm going to choose a point E prime somewhere along here. And if I could draw this half decent, it's going to be somewhere like that. I'm going to choose E prime on the ray such that this is the same length as this. So I'm going to pick E prime, sorry, that's E prime, so that AE prime is congruent to AB.
Okay.
And then when you finish off the triangle here by putting in this line, then this triangle right here is going to be congruent to this triangle by side angle side.
Right.
So that's the first piece of the proof. So I think you understand. So let E prime on the ray A prime D prime such that A prime E prime is congruent to AB. 3. Now let's spell it out. Spell it all out. Since E prime A prime, E prime A prime is congruent to BA, E prime A prime C prime, that angle E prime A prime C prime is congruent to angle A. We could also call angle A, if we want to see some of the parallels here, we could also call it angle BAC, comma, and our remaining side, A prime C prime, there should be a prime there, and A prime C prime is congruent to AC. Then I know triangle order matters. Triangle E prime A prime C prime is congruent to triangle BAC. Follow all that? Okay, now dividing this into two isosceles triangles, picture can get a little bit messy. We're going to think about this now. If we were to divide this, if I add this blue line segment, and if I would do it right,
Is this 6, 7 or 6, 6?
this is
6, 6.
I hope I labeled it right.
It's supposed to be 6, 6.
6, 6, side, side, side. Okay, sorry. Or did I skip the theorem? I might have gotten a little bit anxious and skipped the theorem.
You might have. 6, 6.
Having the exercises in the middle always makes it a little bit harder to keep track of where you are.
Why don't you write
So,
6, 7?
6,
Side,
5.
side.
Theorem 6, 6. If a triangle has two angles congruent to each other, then the side opposite these angles are congruent. If a triangle has two angles congruent to each other, then the sides opposite these angles are congruent. Oh, that is an important theorem about isosceles triangles.
That's theorem 6, 6.
Yes. Shoot. I don't know that we need it for this. So theorem 6, 6, in case I have to reference it. So going back to isosceles triangles, when you have an isosceles triangle, we already proved, what's an isosceles triangle first of all?
Isosceles triangle.
It
Triangle
has two sides that are congruent.
Two sides are congruent. So we have two sides congruent. We already proved that if you have an isosceles triangle, then the base angles are also congruent.
Right.
6, 6, which we'll come back to, says that if the base angles are congruent, then the sides are congruent as well. You have an isosceles triangle.
Almost the exact opposite of that one.
Yeah. So one is if you have the sides the same, then the base angles are the same. This one says if you have the base angles the same, then the sides are the same. So I don't know if we are going to use that in this. We can use it if we need to. I don't know if we're going to need to. We'll come back and prove that after this, but because we probably will, because I just divided this into isosceles triangles.
How many lines do you think you're going to have for 6, 6? Just so I think no space for it.
So it'll be a small one. I don't know how many lines. Should be quick. Okay, but going back to this one. So we intentionally constructed this triangle congruent to this triangle. So we know that this is 1, 2, 3, right? And I also knew that this was 1, 2, 3. Sorry. So there's all our known information listed out there. Maybe get rid of that dotted line the best I can. I divide this picture up, and notice that the blue line divides this outer polygon into two isosceles triangles. You see the two isosceles triangles?
Yeah.
They're on the left side and the right side, right? One of my isosceles triangles right here, point, point, point. And then this is an isosceles triangle. And going back to the theorem we proved about isosceles triangles, their base angles are
The same.
congruent. So with that, I know that this angle is congruent to this angle, right?
Yeah.
Because those are two isosceles triangles. And I know that this angle is congruent to this angle, right? And then, if this piece is congruent to that piece, and this piece is congruent to that piece, then this whole thing is congruent to that whole thing, right? But since this triangle is congruent to this triangle, I already know that this whole thing, the blue angle, I already know that this blue angle is congruent to this. So then angle B prime is congruent to angle B, which is what we were after. Remember, we already had sides, we just need to get one angle was the same and we were good. So all this work was to show that this angle is the same as that angle. So I flipped it down, created my two isosceles triangles, where I knew that their angle sum would be the same as that.
Right. Okay. Right.
So if you understand the picture, I think I can now write out all the words.
I think we do.
Okay, so far in the words, I constructed this triangle down here, so it's congruent to this triangle. Okay, 4. Since A prime B prime is congruent to A prime E prime, since A prime B prime is congruent to A prime E prime, Then triangle A prime, B prime, E prime is isosceles and isosceles, and so by, I don't remember what theorem it was when we proved this, that the base angles of an isosceles triangle are congruent.
Way back there.
It can't be too far back. Theorem 6.3. And so by 6.3, angle A prime, B prime, E prime, angle A prime, B prime, E prime is congruent to angle A prime, E prime, B prime. So that gave me the red. That red angle is congruent to that red angle. 5, same exact logic. Since this side is congruent to this side, since B prime, C prime, how do I know that this side is congruent to this side? Well, because I knew that this side was congruent to this side, and this side is congruent to this side. So using the transitive property without stating it for congruence. But since B prime, C prime is congruent to side E prime, C prime, then triangle, what's our triangle now? B prime, C prime, E prime. B prime, C prime, E prime is isosceles. And so its base angle, angle D prime, B prime, C prime, D prime, B prime, C prime is congruent to, we said D prime, B prime, C prime is congruent to B prime, D prime, C prime. Angle B prime, D prime, C prime. Then the angle sum is equal to the angle sum. Then angle B prime is congruent to, hopefully from my picture it's clear what I mean by angle E prime. So then this whole angle is congruent to this whole angle. And that's using postulate number 5.3, right? Equals, added to equals or equals. Okay. Then B prime is congruent to E prime, comma. And we already know that angle B prime was congruent to angle B. Oops, sorry. And we already knew that angle E prime was congruent to angle B. And we already knew, and we already have angle E prime is congruent to angle B. How do I know that E prime is congruent to angle B? How do I know that this angle is congruent to that angle?
Because they're isosceles.
How do I know that this angle is congruent to this angle? I already proved way early on that this triangle is congruent to this triangle. That's the first thing I did. I constructed this triangle down here to be congruent to this. So this angle has to be the same as that. They're congruent triangles.
Right.
So the whole crux of this proof was showing this angle is the same as this angle. Because then it's the same as this angle. And so then we have congruence between this triangle and this triangle by side angle side. We were just trying to show that two angles were the same. So then angle B is congruent to angle B prime. And so triangle ABC is congruent to triangle A prime, B prime, C prime by side angle side. And we're done. Good? Yep, proof's in your books and it's uploaded, but maybe you're just taking a picture of me.
Oh.
would I do that?
I don't know. Hours of footage of me. All right, let's come back and prove this one that we accidentally skipped over. And you said it was Theorem 6.6? So Theorem 6.6. If two angles in a triangle are congruent, I'm not sure how it's worded, but it's going to be something like this. If two angles in a triangle are congruent, comma, then the triangle is isosceles. Right? That's essentially what we're trying to prove.
Yes.
Yes? Woke up just in time for that? Alright.
Had a lot of homework last night.
Yep. Hang in there. We're close. Okay, this is an easy one. Let's see if you guys can piece this one together. I think you can. So if two angles in a triangle are congruent, then the triangle is isosceles. Or in other words, as two sides are congruent.
So the contrapositive of, or the converse of.
We don't want anything fancy like that. If let triangle ABC such that angle A is congruent to angle C. So, draw a picture down here. So here's triangle ABC.
Will you remind me what isosceles mean?
Two sides are the same length. Two sides are congruent. So I know that this angle is congruent to this angle.
I'm trying to prove that.
I'm trying to
AB
prove
is congruent to BC.
that this is congruent to this. And actually, yeah, the author word's a little bit better.
Isn't
He
that-
says prove that the sides opposite the angles are congruent. So in other words, we're not proving that this side's congruent to this. So the author word's better. So the way I have it worded there is kind of bad. We know a little bit more than it's an isosceles triangle. We know that the sides that are congruent are opposite the angles. And I think that's the way the author words it. So bad wording for me on Theorem 6.6. Author has better. But I think you understand what we're trying to prove. So I know the angles are the same. I'm trying to prove that these opposite sides are the same. Yeah, I'm trying to prove that this side is congruent to this side.
Right.
Understood. Kind
Let me draw out the triangle again. I don't know if this is too much of a hint or if this is just confusing. Same triangle, C, B, A. I just flipped it around in the mirror.
Right, weird.
of. Oh yeah.
Okay, here's these two triangles. How does this triangle relate to this triangle?
It's the same triangle.
How do you know? Forget that I labeled the points the same for a second. But looking at your given information, first off, how does this side length compare with this side length?
They're the same.
They're for sure the same, right?
Right. Angle side angle tells us those are the same
Angle
side.
side angle.
Angle side angle tells me that these are the same
Right.
triangles.
So
Two.
thus, because of that, wait.
Now, here's where the order matters very much.
What didn't you say for number 2? Construct two triangles.
Nope.
When have-
We are, notice that in this picture, some random picture ABC, how many different ways do I have the triangle written there?
So
You can think about it as
ACA,
triangle
ACB,
ABC, but you can
triangle
also think about it as triangle
ACB,
CBA.
BAB, BAC,
Actually, that's the same, so flipping those doesn't matter. But
ACB,
BCA, triangle
Yes.
CAB.
ACB.
So there's different ways that you could think about that triangle. So we're thinking about two triangles really in one. So this and this are the exact same triangle. I drew them as two separate triangles to help you think. Right? But since angle A is congruent to angle C, since angle A is congruent to angle C, AC is congruent to CA, AC is congruent to CA, comma, And angle C is congruent to angle A. Then triangle, make sure we keep our ordering right here.
BC.
BAC, if we want to think about it that way.
Well, right there it says ABC. Doesn't matter. Not
Well, just what we proved from here. Looking at this, I told you that angle A is congruent to angle C. Actually, make sure I list out these triangles in the proper order. So the two triangles I'm saying, I'll make them start with whatever was the first angle we said is congruent. So triangle A is congruent with triangle, this one started with A, this one started with C. This one goes to AC, this one goes to CA, and then we're missing B and B. Here's the triangles I proved were congruent. Triangle ACB is congruent to triangle CAB. Triangle ACB is congruent to triangle CAB.
Right, okay.
Oh, yeah, okay.
You with me?
Yep.
Now, just looking at the fact that these are congruent,
That means that the side's the same, right?
ignore the picture for a second. That means that segment AC is congruent to segment CA, segment CB is congruent to segment AB, and segment AB is congruent to segment CB.
Right.
Oh, yeah. Okay.
So then, I know AC is congruent to CA. That was already given information. I know CB is congruent to AB. CB is congruent to AB. And I know AB is congruent to CB. Turns out that's giving me the same information twice because we're talking about the same triangle. But that's what it gives me knowing that they're congruent. Or in other words, this side is congruent to that side.
And that triangle's also an equilateral triangle.
It's not equilateral, sorry.
Yes, it is. Why not?
No. So double line.
Oh, right.
The only other information we extract from this is that AC is congruent to CA. AC is congruent to CA. Yeah, we already knew that. But the new thing we got is that AB is congruent to CB and BC is congruent to BA.
Right, but CB is the same thing as BC.
Tricky.
Very tricky.
Yeah, so you're just looking at a triangle and seeing two triangles inside of it. They're congruent to each other.
Right. Just relate with the points.
So therefore, triangle ABC is isosceles. It's actually, we know a little bit more than that. We know that the sides opposite the angles are congruent. And I think that's the way they often words it. Ooh, do we have time to power through? How you guys doing?
Pretty good.
We gotta talk about angles being less than and greater than each other. Will that be a bit much?
Not too much. You just finish writing all this stuff down.
Maybe we can. 18 minutes. Shoot.
Never enough time.
Let's see. I know I spent too much time going over guys' test today. Shouldn't have done that. Should have been quicker. I want you to know how to write these proofs correctly.
I have
And-
a question on the new test. Can I ask real fast?
Yeah. Okay. We'll call that for material. Taking us 3 weeks for chapter 6 is too bad, but oh well. So we'll call that for material. Continue chapter 6 next time. You can start digging into those proofs. So do your tests first, and then start doing your proofs. I may want to read your chapter 6 proofs and see how those are coming along, and make sure that you guys are actually proving. Yeah. So I may want to read them. So write your chapter 6 proofs very legible, especially for section. When do we start dropping out a bunch of these proofs?
6-5.
6-6.
I think
It's
6-6
just,
is when we.
The entire thing.
But we only have some free proofs as a thing, right?
Yeah.
Oh, okay. That's
So-
also.
So it's like 15 proofs in one of those.
There is. it's
Let's see.
section.
After the side angle side stuff, 6-4. Let's see. How far do you guys need to go?
We went to 6-6 last time. I mean 6-7.
Last time I got through a little bit 6-5. That's how.
Exercise group. So for exercise group 6-9, let's say exercise group 6-9. Write those proofs really good and turn. I want to read those ones. So for exercise group 6-9, let me actually see your proofs. I want to read them and see how things are going.
What's homework?
Homework goes to, I mean, ultimately you're going to have to do all the chapter 6 homework so you can go as far as you want. But I think as far as what we've covered so far, we didn't do right angles yet. So you should be able to do through exercise group 6-11.
Okay.
So 2-6-11. Through.
Through 6-11
Through 6-11.
is what you can do so far. Okay, this is just homework talk, so we can turn this off.